Hi kids, in this video we'll continue with rectilinear figures from Concise Mathematics, Selina, exercise 14C. We have already done till sum number 7. You can click on the I button or go in the description box and see it. Okay, now let us see sum number 8. Now 8 says, prove that the bisector of the internal angles of a rectangle form a square. I've drawn the diagram. See, I've taken a rectangle ABCD. The bisector of internal angles means suppose AK bisects angle A, BI bisects angle B, CI again bisects angle C, and DK bisects angle K. Okay, we need to prove that IJKL is a square. So for square we need to prove that all the angles are 90 degree. Then it will become a rectangle. And if we can prove that the adjacent sides are equal, our work is done. Now look carefully. AK bisects angle A, which means this angle will be 45 degree each because the entire angle is 90 degree, which means angle JAB is equal to JAD. JAD is equal to 90 by 2, that's 45 degree. Why? Because AK bisects angle A. We have already written that. Okay. So this is 45. Similarly, this angle will be 45, isn't it? So we can say that angle JBA, look carefully, JBA is equal to angle JBC is equal to 45. Why? Because BJ or BI, whatever, BJ bisects angle B. So this is 45, this is 45. Similarly, this, they all will be 45 degree each. Am I clear or not? Isn't it? Similarly, we can say angle LCB is equal to LCD is equal to 45, and LDA, just look at the diagram, LDA is equal to LDC is equal to 45. So we just got that these angles are 45 degree. We know this. Now look carefully. This angle is 90. Why? Because in triangle ABJ, angle AJB plus 45, look carefully, plus 45 equals to 180. Angle sum property, which means angle AJB is 180 minus 90, that's 90 degree. So we got this as 90 degree. Now once this is 90 degree, this has to be 90 degree, vertically opposite angle, which implies IJK equals to 90 degree vertically opposite angle. In the same fashion, we get this as 90, so this will be 90. So in triangle, just look carefully, DLC angle DLC plus 45 equals to 180, which means DLC equals to 90 degree. Now this is angle sum property. So if this is 90, this has to be 90. ILK is equal to DLC is equal to 90. Why? Vertically opposite angle. Done. Now look at triangle. So these two angles are 90 degree. Look at triangle BIC. Triangle BIC if you look. So angle BIC plus 45 equals to 180. Same angle sum property, which means angle BIC equals to 90 degree. So this we got 90. Okay. Then look at triangle, I should say, which triangle? AKD. Just look carefully. Angle AKD plus 45 plus 45 equals to 180. That's angle sum property, which means angle AKD equals to 90 degree. So all the angles, now we just proved that all the angles in the quadrilateral IJKL is 90 degree, which means it's a rectangle. All angles of IJKL is equal to 90 degree each, is equal to 90 degree, all the angles, which simply means that IJKL is a rectangle. Okay, but we need to prove that IJKL is a square. So if you can prove in the rectangle the adjacent side are equal, our work is done. Which means if I can prove that IJ and JK are same, our work is done. Okay, look at AKD, triangle AKD. See, angle KAD is equal to KDA is equal to 45 degree, which means it's an isosceles triangle. And if it's an isosceles triangle, AK and KD will be same. AK equals to KD. Done. Now, look at triangle AJB, and triangle DLC. We'll try to prove them. They are congruent. Look carefully. AB equals to DC. We know this. AB equals to DC. Opposite sides of a rectangle. JAB, angle JAB is equal to angle LDC, 45 degree each, marked. JBA, angle JBA is equal to angle LCD, again 45 degree each, which means these two triangles are congruent, which means triangle AJB is congruent to triangle DLC. Okay, AJB and DLC are congruent. If they are congruent, we can say that AJ and DL are same. AJ equals to DL by CPCT, isn't it? Now suppose this is 1 and this is 2. So AK, look over here, the last portion, very easy. See, we got AK equals to KD. AK can be written as AJ plus JK. KD can be written as LD plus LK. This cancels out because AJ and DL are same. We have already proved that. Which means simple, JK equals to LK. And in a rectangle, if the adjacent side are equal, it's a square. Which simply means that, which implies, you write after this, that IJKL is a square. Done. Pretty easy. Just find the angles, 90 degree each. It becomes a rectangle. Show that the adjacent side are equal. Our work is done. Okay. Which implies that IJKL is a square. Okay. Now let us look at the next sum. Now look at number 9. In a parallelogram ABCD, so I'll just draw parallelogram ABCD. Okay, ABCD. The bisector of angle A meets DC at P. So suppose this is P. So the bisector of angle A meets DC at P. So if this is X, this will be X degree. Okay, and AB is twice AD. So if I take AD as Y, this will be 2Y. No doubt in that. Prove that BP bisects angle B, which means this angle and this angle are equal. We need to prove. And angle APB is 90 degree. Pretty easy. Our main motive is to show that PBC is an isosceles triangle. Then our work is done. First part. Now look carefully. In this triangle first, ADP. In triangle ADP. Just look. First of all, BAB, angle PAB is equal to APD is equal to X degree. alternate angle, which means if this is x, this has to be x, which transforms triangle ADP is an isosceles triangle. And if these two are the base angles are equal, then AD and DP will be same. AD equals to DP. Any doubt? I don't think so. Suppose, and this was y, so I've taken this as y. Right? Okay. Now, AB is equal to CD equals to 2y. AB and CD are opposite sides and they are equal in parallelogram, okay? So if this is 2y, this is 2y. If this portion is y, then CP will be also y. No doubt in that. BC, of course, is equal to AD is equal to y. Okay? Very easy. This was 2y, this was y, this is y. So this has to be y because this is 2y and this sides are equal. Now look carefully. In triangle, PCB, PC is equal to BC, which means this angle and this angle will be same, which means angle CPB is equal to CBP, isn't it? So, and this angle and this angle are same. Suppose this is 1. We know that angle CPB is equal to angle PBA, alternate angle, isn't it? So comparing 1 and 2, this angle is equal to this angle and this 2 are equal, which means these two angles are equal, which means comparing the above two, we can say that angle CBP, angle CBP is equal to PBA. So if these two angles are equal, it simply means that BP bisects angle B. Done, the first part. Now we need to prove that angle APB is 90 degree. Pretty easy. Look over here, these two angles are equal and these two angles are equal. So if I take this as Z, this will be Z, this will be Z, no doubt in that. Okay, suppose this I have taken as Z. Let. Now look carefully. 2x, angle A plus angle B is 180 degree. Co-interior, they're supplementary. Which means, can I write 2x plus 2z equals to 180 degree? Which means x plus z is 90 degree. Done. Now look at triangle PAB. Triangle PAB. Angle APB plus x plus z equals to 180. This is 90. So angle APB plus 90 equals to 180. Which means angle APB equals to 180 minus 90. That's 90 degree. Done. Pretty easy. Clear? Just prove that these two are, this basically is an isosceles triangle. Our work is done for the first part. Second part is very easy, okay? Now let us do it the next sum. Now look at number 10. Point M and N are taken on diagonal AC of a parallelogram ABCD such that AM equals to CN. Prove that BMDN is a parallelogram. First draw the diagram. I'll draw. Just look carefully. A, B, C, D. A, B, C, D. They have told on the diagonal AC, I'll take 2 points M and N says that AM equals to CN. That is given to us, okay? This length is same. Prove that BMDN is a parallelogram, which means B, if I join this, and this, B, M, D, N. That's a parallelogram we need to prove. B, M, D, N. Pretty easy. I'll draw the diagonal. Now, in a parallelogram, the diagonal bisect each other, which means if we can show that OM equals to ON, our work is done, because DO equals to OB we already know. See, DO equals to OB. We know this. Okay. Now, AO equals to OC. The diagonal of the parallelogram bisect each other. Now AO equals to OC. AO can I write as AM plus MO, and OC can I write as ON plus NC. Now NC and AM are same, or CN. Okay, CN and AM are same, which means MO and ON are same, which means this and this length are same. So in the quadrilateral, we can say BMDN. The diagonal bisect each other, which means BMDN is a parallelogram. Very easy. Just look over here. Isn't it? Pretty easy. Just need to prove that the diagonal bisect each other. Our work is done. Okay. Now let us look at the next sum. Now look at this sum number 11. In the figure ABCD is a parallelogram. AP bisects angle A, we need to prove. BP bisects angle B, we need to prove. And DAP, this angle, plus CBB with this angle is equal to APB, this angle. And they've given that AD equals to DP equals to PC. The first thing, AD and BC are same, which means AD, look, AD equals to BC, which means AD will be equal to DP, will be equal to PC, will be equal to BC. No doubt in that, isn't it? Now, look at triangle ADP, angle APD. This angle and this angle will be same because AD and DP are same. APD and DAP will be same. Suppose x degree. Why? Because AD is equal to DP. It's an isosceles triangle. So I've taken this as x, this as x. Now DC and AB are parallel, which means if this is x, this has to be x too. Which, now look carefully, DPA is equal to PAB is equal to x. Okay, DPA, which means this angle and this angle will be x degree each, alternate angle, which simply means that, you know, DAP, angle DAP, this, and PAB is x, which means that AP bisects angle A. Done the first part. This was x, this was x. So this is x, this is x. So these two angles are equal, which means AP bisects angle A. Done. Number 2. Same fashion. See, PC equals to BC in triangle PCB. So this angle and this angle will be same. Angle CPB is equal to angle CBP equals to y. Okay, this is y. And why they are equal? Because CP equals to BC. It's an isosceles triangle. Now this angle and this angle will be equal, alternate. Angle CPB is equal to PBA is equal to y, alternate angle, which clearly means these two angles are equal. Angle CBP is equal to angle PBA equals to y, which means that PB, or BP rather, bisects angle B. Done. Okay, now we need to prove that this angle plus this angle is equal to this angle. Pretty easy, just look over here. I can say that 2x plus 2y equals to 180. Look at the figure, co-interior. The adjacent angles had to give 180 in a parallelogram, which means x plus y equals to 90 degree. Done. Now, if you look at triangle PAB, angle APB will be 180 minus x plus y. This is 180. Angle sum property, because these three angles add to give 180. So 180 minus 90, that is equal to 90. So angle APB is equal to 90 degree. And 90 degree is what? X plus y. Now, instead of x, can I write angle DAP? Look carefully. Instead of y, can I write CBP? Definitely. Proved. Clear? Pretty easy. First, prove that this is an isosceles triangle. Then BP bisects angle B, and then the angle sum property will get the answer. Now let us look at the next sum. Now look at sum number 12. ABCD is a square, so I'll draw a square. A is joined to a point P on BC. So A, B, C, D. A is joined to a point P on BC, and D is joined to a point point Q on AB. So this is Q. Suppose AP equals to DQ. This is given to us. AP equals to DQ. Prove that AP and DQ are perpendicular to each other, which means if you see this is the point of intersection, suppose O, then any one of the angle, if you prove that this is 90 degree, our work is done. Look carefully. Take triangle ADQ, and triangle BAP. If you look carefully, AP and DQ are given equal. AP equals to DQ. This was given to us, isn't it? Angle DAQ is equal to ABP, that's 90 degree. ABP, that's 90 degree. This was also given to us because it's a square. And AD is equal to AB, that's the adjacent side of the square. They have to be equal, which simply means triangle ADQ is congruent to BAP. Now, if they are congruent, we can say that this is RHS because the hypotenuse is equal. One of the angle is 90 degree, one of the side is equal. Okay, so RHS. Now, if they are equal, you see this angle and this angle will be equal. Angle ADQ is equal to BAP, equals to BAP, that's CPCT, isn't it? Then this angle and this angle will be equal. Again CPCT, angle AQD is equal to angle APB, that's CPCT. Suppose I take this as X, I take this as Y. So this was X, this is X, this is Y, this is Y. Okay. Now look at triangle DAQ. This is X degree, this is Y degree, plus DAQ will be 180, isn't it? Angle sum property, which means you can say X plus Y. DAQ is 90 degree, we know this. So this is equal to 180, which means X plus Y is 90 degree. Now look, if you look at triangle AQO, I'm talking about triangle AQO. Just look, X plus Y plus angle AOQ. X plus Y plus angle AOQ will be 180 degree. Angle sum property. X plus Y is 90, we already know. So 90 plus angle AOQ equals to 180, which means angle AOQ equals to 90 degree. Which means this angle is 90 degree. And if this angle is 90 degree, it clearly means that AP is perpendicular. AP and this is DQ are perpendicular to each other. Pretty simple. We just take these two triangles ADQ and BAP, improve them congruent, our work will be done. Okay. Now let us look at the next sum. Now look at sum number 13. In a quadrilateral ABCD, AB equals to AD and CB equals to CD, prove that AC bisects angle BAD and AC is the perpendicular bisector of BD. We just draw the diagram. Suppose I take A, B, C, D like this. AB equals to AD, CB equals to CD. We need to prove that AC bisects angle BAD, which means this angle and this angle are equal. And we need to prove that AC is perpendicular bisector of BD, which means BO and OD is equal, and one of the angle is 90 degree. Our work is done. Now look carefully. Congruency is very important in all these sums, Look at triangle ABC, and triangle ADC. AB is equal to AD, this is given to us. BC is equal to CD, this is given to us. AC equals to AC, that's common if you see, which clearly means that these two triangle ABC is congruent to triangle ADC, isn't it? Side. Once they are congruent, these two angles have to be equal CPCT. So angle BAC implies angle BAC is equal to angle DAC CPCT. And if these two angles are equal, we can simply say that AC bisects angle DAD. First part is done. I don't think any problem, okay? Now, AC is perpendicular bisector of BD. Pretty easy, just look over here again. Look at triangle ABO and triangle ADO. AB equals to AD, again congruency. AB equals to AD given. AO equals to AO, that's common. This was given, isn't it? Just now we did BAO. Angle BAO is equal to angle DAO. Proved. Just now we have proved this. Which means these two triangles are congruent. Triangle ABO is congruent to triangle ADO. And the reason is side angle side. Side angle side. So if these two triangles are congruent, then BO equals to OD. Implies BO equals to OD. That's CPCT. Which means AC bisects BD. Now perpendicular, which means this angle, we need to prove 90 degree. Very easy. These two angles are equal. Look, angle BOA equals to angle DOA. That's CPCT. Suppose X, isn't it? Now X plus X is 180 because that's a straight line, that's a linear pair. So 2X equals to 180, which means X equals to 90 degree, which means angle BOA equals to angle DOA equals to 90 degree. Look carefully. So the angle is 90 degree and BO equals to OD, which means we can say AC is a perpendicular bisector of BD. Isn't it? Pretty easy. Okay. So in this video, keep it till here. In the next video, we'll see the rest of the sum. Till then, take care. And if you like the video, do subscribe and share.